The resistors are the most common passive component in electronic circuits. A resistor is manufactured in a specific value of ohms. The purpose of using a resistor in circuit is either to limit the current to a specific value or to provide a desired voltage drop. The power rating of resistors may be from 0.1 watt to hundreds of watts. There are 4 types of resistors: wire wound resistors, carbon composition resistors, metal film resistors, and carbon film resistors. Wire wound resistors are made of nickel chrome alloy wrapped around an insulating core such as ceramic porcelain, bakelite, pressed paper, etc. Wire wound resistors are used for high current applications. They are available in wattage ratings from 1 to 100 watts or more. One type of wire wound resistor is called as fusible resistor, enclosed in a porcelain case, is designed to open the circuit when the current through it exceeds certain limit. Carbon composition resistors are made of fine carbon or graphite mixed with powdered insulating material as binder in the proportion needed for the desired resistance value. Carbon resistance elements are fixed with metal caps with leads of tinned copper wire for soldering the connection into a circuit. Carbon resistors are available in values of 1 ohm to 22 mega ohms and of different power ratings. Metal film resistors are manufactured by 2 processes. Thick film resistors are pasted with metal compound and powdered glass, which are spread on the ceramic base and then baked. Thin film resistors are processed by depositing a metal vapor on ceramic base. Metal film resistors are available from 1 ohm to 10 mega ohms up to 1 watt. In carbon film resistors, a thin layer of carbon is deposited on the ceramic base or tube. A spiral groove is cut over the surface to increase the length of the foil. Carbon film resistors are available from 1 ohm to 10 mega ohms up to 1 watt. All the 4 types of resistors are coated with synthetic resin to protect them against mechanical damages and climatic influences. Resistors are specified normally with the 4 important parameters: types of resistor, nominal value of the resistors in ohm or kilo ohm or mega ohm, tolerance limit for the resistance value in percentage, loading capacity of the component in wattage. Resistors can also be classified with respect to their function as fixed resistors, variable resistors. In fixed resistors, the nominal value is fixed. These are provided with a pair of leads. Variable resistors are those whose values can be changed. The resistance value can be set at the different levels with the help of sliding contacts. These are known as potentiometer resistors or simply potentiometers. It is provided with 3 terminals. They are available with carbon tracks and wire wound types. Trimmer potentiometers can be adjusted with the help of screwdrivers. Special resistors are also produced whose resistance varies with temperature, voltage, and light. In PTC resistors, as the temperature increases, the resistance increases non-linearly. In NTC resistors, as the temperature increases, the value of resistance decreases non-linearly. In VDR resistors, the resistance falls non-linearly with increasing voltage. VDRs are used in voltage stabilization, arc quenching, and overvoltage protection. LDR is also known as photoconductors. In LDRs, the resistance falls with increase in intensity of illumination. The LDRs shall have an exposed surface to sense the light. They are also used for measuring the intensity of light. Commercially, the value of resistance and tolerance value are marked over the resistors by color codes or letter and digit codes. There are 4 bands of color. The first band shall be the one nearest to one end of the component. The first 2 color bands indicate the first 2 digits in the numeric value of resistance. Third band is the multiplier. The fourth is tolerance value. If the color band on a resistor are in the order red, violet, orange, and gold, then the value of resistor 27 multiplied by 10 to the power of 3. The value of the resistor is 27,000 ohms with plus or minus 5% tolerance. For less than 10 ohms, the third band will be either golden or silver. Large value resistance are expressed in kilo ohms and mega ohms, represented by letters K and M. In letter and digit code system of coding, numbers and letters are used. We can measure the value of the resistors by using a multimeter or an ammeter. This is a ceramic fusible resistor. The value printed on it is 10 ohms, 10 watts. This can be checked with a multimeter in ohms range. We select 200 ohms in the meter because the resistor's value is 10 ohms. Now we touch both ends with multimeter probes. The meter indicates 9.6 volts. The code value of the resistor is 10 ohms and tolerance is plus or minus 5%. The measured value is 9.6 volts. The resistor is good.